Now in algorithm A and algorithm B, what we are doing here is we are building an algorithm, different algorithms, such that here there might be at the backend very simple equations. Let's assume that there is a simple equation. Okay, don't worry about the linear regression because it's a classification problem. Regression will not be helpful here. Okay, first of all. Second thing, here we are using some other classification technique and we are classifying 1 and 0. So this looks very simple, this looks complicated. First point. Okay. Second point. Say for training you got a 90% accuracy with algorithm A. For test also you got say 89% of accuracy. Okay. Now in training you got 100% of accuracy using algorithm B, and in test data say you got again 89% of accuracy. For your sake Naga, let me just increase the accuracy for this. Let's say it is 92%. Okay. See, what you are thinking is we already have the label for training data set based on which the algorithm is built, but then that algorithm has to predict again for the inputs what is the output. But anyways, that point will be cleared by looking at this simple two cases. The first thing was in case B, algorithm is quite complicated, difficult to interpret. Second thing is the training data set error or the accuracy and the test accuracy is more or less same. Okay, and in the second data set you have complicated your algorithm so much, inclined towards your training data set. You have done so much calibrations or you have changed so much in your algorithm that your algorithm is giving you the accuracy of 100% for training data set, but for test data set it is giving 92% only. So now in data science area, case A is preferred than case B. I'll tell you why. Anyways, this was supposed to be discussed in week 6th or 7th, but anyways, I'll tell you the reason why. Because let's say this in simple English terms, your algorithm is able to generalize from training data set to test data set. That is the reason there is a consistency. For algorithm B, you have already tweaked your algorithm so much to give 100% of accuracy for training data set that for test data set you are getting 92% of accuracy, which is better, but that is not considered to be better because your algorithm is not able to generalize in a same way for test data set as it has done for training data set. So your algorithm is not able to generalize from training data set to test data set with algorithm B. But for algorithm A, it is able to generalize. Okay. So whenever we build the algorithm on the training data set, it's just that you will take one algorithm, it will look at the training data set, inputs and outputs. Based on that, it will come up with some equations at the back end. Okay. And then it will again predict for the training data set, and then we will look at the accuracy for training data set and then for test data set. If you try to improve the accuracy for training data set, say 100%, then you should make sure that for the test also it is near to 98 or 99%. Then only we can tell that our algorithm is able to generalize from training data set to test data set. Otherwise, it will be a risky case for us. So the cases which we are talking, when the accuracy for training data set is very high, but it is not able to generalize for test data set, then it is called overfitting. It is called overfitting. Overfitting in the sense you have tweaked your algorithm at the training level so much, you have fitted your algorithm so much at the training level that it is now considered to be overfitted now for training data set, such that it is not able to generalize for test data set. Okay, this is called as overfitting. Now there is something called as underfitting also that we will discuss in later sessions, because I want to discuss few more things here. Anyways, So for binary classes, you can always look for the accuracy using confusion matrix. So going back, how to do this in Python? Okay, same thing, numpy, pandas, matplotlib, sklearn, same thing, import linear model. Now don't worry about all the different things. You can use the pandas and you can import the data frame which I have explained you yesterday. Once you import the pandas, the line which we will be changing here, if you remember from yesterday's example, it was reg equal to linear underscore model dot linear regression, right? Here there is one simple difference. You don't have to worry about this. This will come under advanced things if you want to write anything under brackets. So it's just that you have to write linear regression equal to linear underscore model dot logistic regression. Instead of linear regression, you are writing logistic regression. And as I told, reg is a variable. I can use anything here, right? So in this case, I have used CLF underscore multi. It's okay, it doesn't matter. You can use anything. That is the only one difference. And score, yesterday if you remember, for linear regression, how did you predict the score? Reg dot score, variable dot score. Here also, variable dot score, simple. Okay. Now, the important thing which I wanted to tell you is, we have to split our data set. See, I will not be running the algorithms in the class. You have to practice at your home, and then if you have any questions, then we can discuss in the doubt sessions. There will be separate support sessions on the doubts. There we can discuss. Here I'm just telling you the method how to write it in a Python coding language. So before implementing logistic regression, we have to split our data into test and training data set, right? It's very simple. You can do, if you have say 100 data, you can directly take 70% into training using top 70% of the data, top 70 data, and last 30 data into test data, right? 70-30. But then by this you are biasing your data set. If you remember, this is not a simple random sampling, right? We should always use probability sampling methods. We should not use non-probability methods. So what is a simple random sampling method says? It can be every event or every sample has an equal probability of getting selected, right? So from Skill-Lync, there is a separate function inside Skill-Lync. So I have written Skill-Lync dot model selection. If there is one more function inside, then I would have written dot something. But I already know. So this thing will come to know by practice only, guys. Okay. Even I also sometimes get confused, so I will use the help of Google. This function train underscore test underscore split is a function which is inside of model selection, and this model selection is inside library called Skill-Lync. Okay. So now what I am doing, we have the data set X and Y. Now we have to separate that X and Y into train and test. So for training data set, you will have X train, Y train. For test data set, you will have X test, Y test. Okay, and this will be the same terminology which will be used till end of the course. Okay, so whenever you are going with supervised learning, you will have the same terminologies. X train, Y train, X test, Y test. Did you understand this 38 highlighted one? We have 4 variables now. Now, these 4 variables get the different random samples. How? Say this is the function which is already inbuilt for simple random sampling, train underscore test underscore split, and then you have to write the dataset name. But for in my case, the dataset's name is, or the data frame name is digit. It's digit. Yesterday's case, it would be area, bedroom, and age. So this is say our data frame. This is our data frame. Then X would be area, bedroom, and age. Y would be price. But for this example, I have taken X as data, only data, one column, which is X, say data, and Y is one column, which is say target. So if you want to compare from the previous example, you can write it in this way also. Simple. You can take the same example and you can write it in the same way here. You can write it like this also. I'm just taking different data sets so that you can get used to it. So this is your X, this is your Y, and how much percentage you want in test data set. Say if you want 0.3, that means 30%, then it will automatically adjust 70% into training data set. Okay, these are just arguments, okay, inbuilt argument for this function. If I'm writing 0.3, then 30% of the data will go into X test and Y test based on what is input and what is output, and 70% of will go into X train and Y train. You can print and check it if you want. Now the important thing is, what is the significance of this random state equal to 5? What is the significance of this? It can be 1, it can be 0, it can be 100, anything. It can be anything, any integer. I'm just writing 5 for my analysis. So let me tell you what is the significance of this. What happens if you don't write that? Say I have 10 data sets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say this is X. You have lot of X1, X2 and so on. Let me just write X and Y. Now if I use 70-30%, say in my test data set I am getting 2, second index, fourth index and 10th index. Okay, because 30%, right? So 3 data points. Now say if I don't use this syntax of random state, say if I don't use this in my analysis, then if I run the algorithm again, then there is a high chances that it might choose different 3 data points in test. Say this might be 1 now, 2 and 4 in the test data set. If you run it again, there could be a chance that it might choose 2, 3, 5 or 5, 6, 7 something. But if I'm by writing this random state, just by writing random state, you are making sure that by running your code again and again, you are making sure that in your test data set you always have 2, 4 and 10th index observations. You have only these 3 observations. This observation should not change because it's a random sampling, right? It might change. So but for our analysis, once you do the random sampling, it should not change, right? But we have to run the code again and again, so it might change again and again. So for that we have to just write random state. So you can write 0, 1 or anything. If you write 0, you might get 3 different samples. If you write 1, you might get 3 different other samples into test data set. If you write 2, you might get 3 different samples into test data set. But whatever you write 0, 1, 2 or some 99 or 98, but you should write for that one Python file, you should maintain that consistency. Otherwise you will get the slightly different results. Every time when you run the model, you will get slight different result because every time you are taking different samples into test data set. Did you understand the significance of random state? Right. So now we have 70% in training, 70% of Y in training, and then 30% of X in test, 30% of Y in test. So now we have 4 variables. So I have assigned logistic regression to one variable, like yesterday only. Like yesterday, I have to do variable dot fit x comma y. Yesterday we didn't split, if you remember, training and test. Today we have splitted it. So variable dot fit x train comma y train is built on training data set. So now if you look further, what you want to do is you want to predict for test data set, right? So what you can do is just write new values for y predict, variable dot predict, give some new x test. We already have the x test, right? From here, just write, give those x test here, and then you will get y predict. Okay, we have given some random new values, right, for testing yesterday, like this. But in this case, we have already splitted training and test, so I'm directly incorporating test here. Okay, and that is assigned to y predict. Now for the test data set, you have y predict and y actuals. You have y predict and y actuals. Now again, you can form a confusion matrix out of it. You can form a confusion matrix out of it, and then you can calculate the accuracy, and that accuracy can also be given by dot score. If you want to predict the accuracy for training data set, that also you can do it. So from the previous session, everything is same. It's just that we are splitting the data in this case now. So from now on, whenever you do the project on machine learning, you should start splitting your data set into training data set and test data set. That is the first step. Second step, build your model on the training data set. Third step, predict your new outputs for the test data set. Fourth step, calculate the accuracy for test data set. If you want to calculate the accuracy for training, you can also do that for the same. Okay. Now, if you want to visualize this confusion matrix, then what you have to do, from Skill-Lync, there is a separate function or module which you can import by name matrix. In that matrix, what you have to just write, just assign a new variable cm matrix dot confusion matrix, which is a function. And we know confusion matrix is built on output values, right? Predicted outputs and the actual outputs. So y test and y predict, and then you will get a confusion matrix. So this will give you confusion matrix. So what is the first step? Import the necessary modules or the libraries. Second step, import the data using pandas. Third step, do the lot of exploratory data analysis on that data set or the data frame. Try to gain as much as knowledge from that data set. Try to absorb that data set so that using your domain knowledge, you should be able to understand the data, which would be helpful when you predict something in the later part of the coding. How will you give the data? Just assign this new data to df. Say I have given you a data set in Excel format or CSV format. You have to just import that CSV format using pandas. This is the syntax. pd.read underscore cv, and then import that CSV or Excel file. From 6th week, you will get the data sets. But till now, till 5th week, you have to do a lot of mathematics on the pen and paper only. You can get the intuition about what is this all about machine learning and how we are going forward with machine learning course. That's the reason I have given a lot of mathematical questions in the challenges, pen and paper questions and coding. But from 5th, 6th week, you will get the projects with the data sets. Okay. So now important thing to note here is how to import the CSV file or data set that is stored in the data frame. Then play around with that data frame, then split that data frame into test and training data set, build your model on the training data set, okay, and then do the prediction for your test data set and calculate the accuracy using the score function. Or you can, if you want to visualize, you can visualize using confusion matrix. Till now we have learned only 4 libraries: NumPy, Pandas, Matplotlib and Skill-Lync. there is a separate library by name math. For example, there is a separate library called math in which you will have some mathematical functions if you want to do it. It's up to you. So these are the 5 libraries which you have used till now, and there will be 6th library which we'll be using in the future session, which is TensorFlow. But let's stick to these 5 libraries, and if you can play around with this 5 or 6 libraries, then you can become a data scientist and you don't have to worry about other libraries. Data scientist and machine learning is built on only 5 or 6 libraries, and in future if you want to go for advanced analytics, then you can have lot more different libraries. But to become an intermediate machine learning engineer, this is enough. Okay, so going to the challenges. Derive log loss function, gradient descent on paper, and replicate it in Python. So if you're not able to do this first problem, it's okay. But log loss is very simple. You have to just apply log. But if you're not able to do it, it's okay, because anyways we'll be doing it in the advanced sessions. What are the different loss functions for classification? I have already told you one is log loss function. Don't worry about first and second. If you're not able to get it, it's okay. I want you to give a try. Third problem, what is one-hot encoding? Okay, this is important. I have taken one example. No, say there was one example like this. X1, X2, X3, Y. So X1 is age of a person, X2 is income, X3 is a gender. Let's say in the gender, I have male, female, so on. Your algorithm cannot read these categorical variables. It's better if you convert your categorical variables into numbers first of all. That would be a better way to do it. It will be better if you can convert your categorical features into numerical features. So it's very simple, right? You can write male, female as 1 and 0. Male as 1, female as 0, or female as 1, male as 0 as per your analysis. But you have to maintain that consistency in your analysis. So converting that categorical into numbers are called as dummy variables. Okay. So from this dummy variables only, did you understand dummy variables, guys? In terms of mechanical example, say if you have one column as say vehicle name, say Audi, Mercedes, Porsche, you have say different names, and you want to use this in your analysis, then it will be better that you convert your categorical data into numerical data using dummy variables. Okay. Now, say if you have 2 categories, then you can just split that into 1 and 0. Say if you have Mercedes-Benz, Audi, Porsche, for example, there is one feature or column where you have 3 different names. Then you can use 1, 2 and 3. And then you can replace that feature or the column with this 1, 2, 3. This is called as label encoding. Okay, these are just terminologies. Similarly, there is one more terminology, one-hot encoding, which I want you guys to work on it and come up with and tell me what is one-hot encoding. I'll be asking you in the next class. Okay, and we'll be looking into this log loss function also in the next class, so that once we go into the advanced course, you should have some knowledge about this loss functions. Okay, whenever I tell something, no, try to do that on paper using pen and paper, and that implement that the same thing on the Python. By that you will not forget things. Okay, because in Python everything is just like a 1 or 2 lines of code. If you do it by using pen and paper, then you will remember for lifelong. Okay, so that was all which I had for today's session. Okay, thank you guys, thank you so much. Let's catch up on next Saturday.